Okay, this video is going to follow a similar structure to the last one, so it doesn't necessarily matter which order you do it in, but I would say that it would make sense to do the first one first and then do this one. So if you didn't already watch that, you might want to pause this and go watch that one. If you did, then you know what the kind of pattern was that we went through. I'm going to remind you that you are a mathematician, and mathematicians study patterns, and that's what we're going to do. So I've given you 3 triangles. Hopefully you can see the similarities between them. I'm not going to tell you what they are. I'm going to give you a chance to go ahead and use Pythagorean theorem, which is what hopefully you would think of if I hadn't even told you that, to solve for the missing side, because in each case you do know 2 of the 3 sides. So I'm going to pause the video and we'll join up in a minute. You go ahead and do the work. Either you have this paper in front of you or you're going to sketch 3 triangles right now and work on it on your own paper. Okay, we'll do a quick talk through of these. And just a couple things I wanted to point out, and then we'll go ahead and make some observations. So the first one I think was actually the trickiest in terms of our radical work. Square root of 75, just wanted to do one more walkthrough of how I can think through that. 25 times 3, or you can do the factor tree if you want, but I like to think of it as perfect square factors. So square root of 25 times square root of 3 gives me 5 radical 3 for my simplified answer there. So I've got 5 radical 3. The other 2 came out to whole numbers, x equals 4 and x equals 12. Just want to point out this part right here, when I'm doing 4 radical 3 quantity squared, I thought about squaring both parts. So you could also write it out as 4 radical 3 times 4 radical 3, and then you can see that you're doing 4 times 4, or you could think of it as you're squaring the 4 and squaring the radical 3, and that gives you 16 times 3, which is 48. And then same thing here, 36, 6 squared times radical 3 squared is 3. That gave me the 108. Okay, so hopefully that helps and you can agree with my answers. If not, pause, check my work, and see where you went wrong. Okay, moving on. So we're going to look at conclusions. And I want you to notice, I kind of pointed this out in the beginning, that these triangles are all very similar to each other. So what do you notice about them? Obviously all right triangles, and then maybe based on the last one you were looking for isosceles triangles, not isosceles here, but you should be noticing that the angles are all the same. And I've oriented them the same way just to help us out as we make some conclusions here. So if we're looking at them, I know you're already starting to observe things. So what are you observing, and how can we write that down? Because we want to make some conclusions that are generalized so we can go back to them. So first thing you're probably observing is that the hypotenuse is twice the leg length. Hypotenuse is double whatever you have for the leg. And I'm saying the leg, which really isn't a good idea because you have 2 legs of your right triangle, and they're not the same length. So we're going to have to specify which leg that is. So right now we're looking at it as probably the leg across from the 30 degrees. And what I'm going to go ahead and point out is that the leg across from the 30 degrees is going to be the short leg. Of the 2 legs, it's always going to be the shorter. So there's kind of this informal relationship, inequality relationship in triangles that says the shorter leg will always be across from the smaller angle. So you could actually order the sides, and that's actually how we know that the hypotenuse is the longest side. No angles in the in a right triangle will be larger than 90 degrees, because once you use 90, you only have 90 left for the sum of the other 2. So the hypotenuse is always the largest side because it's across from that biggest angle. And I know you can't see my hands right now, but if you sort of think about making a triangle with your hands, the wider you open your hands, the bigger the span is between the tips of your fingers. And that's exactly the same thing happening here. So this 30-degree angle is a smaller opening, shorter length here, versus the 60-degree angle, larger opening. You're going to need a longer side to connect it. So we're going to refer to that as the short leg, and the hypotenuse is twice the length of the short leg. Let's go ahead and start to write the conclusions down, and then we'll go back and figure out what the rest of the conclusions are. So I'm going to go ahead and name this one. Any ideas for what you want to call this? That's boring, but that's what we're going to do. Yep, it's a 30, 60, 90 triangle, or you can name it whatever you want, but that's what we like to call it. We name it by the angles, just like our 45, 45, 90. And 2 relationships here. So the first one that we've recognized is that the hypotenuse is 2 times the short leg. Okay, and maybe for the sake of simplicity, maybe I'll go ahead and do this one with X's, or you could do S for short leg, or whatever you want. So we're going to call this my 30-degree angle, and 60-degree, we'll keep it oriented this as the same as the one up above. And let's go ahead and recognize that this is the short leg, and this is the long leg, and this is the hypotenuse, obviously. no, nothing new there. And if I'm going to put the relationships on here, then I would say that this is x and this is 2x as one way of representing that. Okay. Okay, other relationship, well, we got to figure out what's going on with the long leg. So that's kind of what I'm zeroing in here on here is what is happening with that long leg. So I'm looking at this 5 radical 3 here, the 4 radical 3 there, and the 6 radical 3. And even as I say them to myself, I'm like, wait a second, they all have a radical 3. Interesting. And what else is interesting about them? Well, that 5, 4, and 6 happen to be numbers that were already in the problem. Specifically, they were the short leg length, right? So it appears that if I take the short leg, and I don't want to just say put a radical 3 there. Mathematically, what are we doing? Yeah, we're multiplying by radical 3. So we're going to take the short leg and multiply by radical 3, and that's going to give me my long leg length. So short leg, or long leg, the long leg is the short leg times the radical 3. So again, we can do that with x's. If we just call our short leg x, then it's easy to note that that's going to be x times radical 3 is my relationship. So we're ready to use that. I'm going to pause real quick and just show you one thing that I think is pretty cool as a generalization of this. So taking the concept that we had up here, but let's go ahead and generalize everything and not use any numbers. So if we're getting this 30, 60, 90 triangle, we're starting with a 60-degree angle here, here, and here. And we could be saying that we're dropping down an altitude in the middle of our equilateral triangle. And that's creating my 30, 60, 90 triangle. So there's my 30, 60, 90 triangle within my equilateral triangle. By starting with an equilateral triangle, here's what it allows me to do. It allows me to recognize that my leg lengths are actually, let's call them 2x. I could call them x or 2x, but I'm going to note that if this whole thing is 2x here, then each part is x. And I'm really just zeroing in on this triangle right here and saying, whoops, I now know that my leg is x, my hypotenuse is 2x. What is this third side here? And I don't know what it is, so I'm going to call that y, and I'm going to solve for that. Because I can't just say right now, it appears that it's going to be x radical 3, but let's convince ourselves of that. So Pythagorean theorem would tell me x squared plus y squared equals 2x quantity squared. And again, that y, or we could have used b there for ABC for my right triangle. X squared plus y squared is going to be, if I multiply this out, 4x squared, squaring both parts. And I'm solving for y, okay, because that's what I'm trying to find is this unknown length here. So I'm trying to get to that. So y squared equals 4x squared minus 1x squared is 3x squared, combining my leg terms. And then taking the square root of both sides gives me y is radical 3 times radical x squared. Radical x squared is x. So radical 3 times x, and usually we write that as x radical 3 because we like the radical at the end. Then we know for sure the x is not inside the radical. So that is a really good way of convincing yourself of what we put right here in variables. Okay, sometimes, oops, sorry about that. Not sure what just happened. Okay, so let's go ahead and see how do we use, we'll put that example aside and look at some examples. How do we use this as a shortcut? Because again, this one is a little bit trickier because it's not like the isosceles right triangles where I technically did have 2 side lengths, or I had one side, the leg pair that I could call x and x, and I could technically do Pythagorean theorem. This one, if you looked at the 3 examples that I gave you to begin with, we had to have 2 sides. So I just set those up for us to be able to make some discoveries. So this becomes a little more necessary for us to have these relationships in order to not use trig. And just a reminder of why we're not using trig. It's not that trig is bad. Trig is a very universal method that allows us to solve a lot of triangles. This is going to allow us to keep answers in exact form for this particular triangle, or the 2 triangles that we call our special right triangles. Okay, so easiest case is when I have my, let's see if I can keep my formulas on here. Easiest case is when I'm given the short leg. Everything goes from the short leg. So I really like it when I have the short leg. Here it is. Not a bad idea to get in the habit of labeling short leg, long leg, and hypotenuse. Long leg is across from the 60. This is 30 right there. It wasn't labeled, but I know that has to be the 30, and short leg is across from that. So I've got my short leg is 3. My hypotenuse is y, and the hypotenuse is the short leg times 2, 2 times the short leg. So therefore my hypotenuse is going to be 2 times 3, which is 6. And x is my long leg, which is my short leg times radical 3. Looking at my second equation here, so I'm going to be doing short leg, which is 3 times radical 3, and that's it. So x is 3 radical 3, and y is 6. Okay, so what happens if it's harder than x? I said that's the easiest case. So let's look at number 2. And in number 2, it looks like I'm given my hypotenuse. So from the hypotenuse, I can look at these. I only have one equation with the hypotenuse, and that one gets me to the short leg. It relates to hypotenuse and the short leg. So I'm going to have to solve for the short leg first. Short leg is x, and my long leg is y. Short leg is across from the 30. So if you need to write something down for yourself, I like to show you a couple ways of doing this. So some of you already have the answer in your head. Not a problem at all if you're not doing it in your head. Let's use those formulas to help me. Hypotenuse is 2 times the short leg. I'm just going to abbreviate SL for my short leg. And my hypotenuse is 22. So I've got 22 is equal to 2 times the short leg, which is x. And now I have an equation that is solvable. I just have to think, how do I solve for x? Solve for x by doing the inverse operation. So 2 times x, undo that by dividing, and I get 22 divided by 2, which is 11. So my x value is 11. So that's the short leg, and now I'm right back in the position that I was right here, where I had the short leg, and when I was looking for the long leg, and here's where you got to be careful, because I know x's and y's are different than what they were in my sort of setup over here. So I like to talk myself through this with words. The long leg was the short leg times radical 3. That's how I got the 3 radical 3. Long leg this time is y, is the short leg times radical 3. So if I do that, my short leg I now know is 11. Not a bad idea to put it on your picture. So this is going to be 11 times radical 3. And there's nothing you have to solve there. You're just done. Okay, so the solving comes when you're kind of going backwards, if you want to think of it that way. A lot of people like to think of it like this. If you have the short leg, you double it to get the hypotenuse. If you have the hypotenuse, you cut it in half to get the short leg. We're just going backwards. Okay, you know the drill, so you can go ahead and try 3 and 4 if you want. Things are going to get a little tricky maybe, so check your work and make sure you're on the right track. So number 3, I'm going to start by labeling that, and looks like I have 7 radical 3 is the which leg? One of the legs. Across from the 60, good, so that's the long leg, which means this is a short leg, and that's the hypotenuse. So there is no formula that relates my long leg and my hypotenuse. We don't have it. Look at our 2 formulas. Long leg is related to short leg, hypotenuse is related to short leg, so I got to get the short leg first. So I have the long leg. I'm going to use this formula to start. And some of you might already be seeing the answer. If you're not seeing the answer, what do? We do a formula, yeah. So the long leg is equal to the short leg times radical 3, which means the long leg, I'm going to plug in what I know. Long leg is 7 radical 3 is equal to the short leg. Short leg is y times radical 3. And then I'm asking myself, how am I solving for y? And mathematically, I solve for, mathematically, I'm looking at this as an algebraic equation now. So the question is, what do I do algebraically? So I'm going to be dividing, because I've got y times radical 3. So divide by radical 3, those cancel. Radical 3 divided by radical 3, those also cancel, and I'm left with y equals 7. So be careful, make sure you're not mixing them up. It looks like we're solving for x because that's the first one we come across, but we're solving for y because we just solved for the short leg. So maybe you're looking at this now and saying, oh, I should have known that because whatever the short leg was times radical 3 had to get me the long leg. And that's a great connection to make. Some of you might have seen that before I just pointed it out. If you didn't, we have an equation that allows us to go through and solve for it. So not a problem. Part 2, hypotenuse is 2 times the short leg. So I've got to do 2 times the short leg. That means that I'm going to do 2 times my short leg, which I just figured out was 7. And therefore my answer here is going to be 14. So those are my 2 answers. Cool. Okay, you're excited for the last one, aren't you? What could I possibly throw at you? Take a look, and I think you'll answer it for yourself. So you've always got to orient yourself. If you want to redraw it, you certainly can. Or like I showed you before, I like to label these: short leg, long leg, hypotenuse. I think we've all got the hypotenuse at this point. The 12 is across from the 60, which makes it the long leg. But wait, the long leg's supposed to have a radical, right? Didn't it just have a radical up here? Doesn't it have a radical there? Yeah, so we could just take the radical off, but we don't really take it off. What do we do? Yeah, we really just divide by radical 3. So here, you can't just take the radical off because it's not there. You can't add a radical and pretend that Miss Fisher just made a mistake. So what are we going to do? We're going to write an equation, and we're going to work it out. So my equation says the long leg is the short leg times radical 3. Same exact thing that I just used right here. Using it again. So long leg is, let's plug in what we know. Let's see, long leg is 12. Short leg is unknown, and we call that x. So long leg equals short leg times radical 3. And now I'm to the point that I am solving for x. So what do? Divide by radical 3, divide by radical 3, and we're kind of done. X equals 12 divided by radical 3, but we know that Miss Fisher's not going to be totally happy with that. So we're going to take our 12 divided by radical 3, and we're going to simplify our radical as we've gotten so good at doing. So let's just rewrite that. We've got 12 divided by radical 3, and we're going to rationalize that. So times radical 3 over radical 3 equals 12 radical 3 over radical 3 times radical 3 is radical 9. Which is 3. 12 divided by 3, we can simplify this, and that is 4. 4 over 1, if you want to think of it that way. So 4 radical 3 is my final answer. So x, that was a lot of work, but all of that was to solve for x. That was just us rewriting this answer in a simplified form, 4 radical 3. So I got 4 radical 3 for x, and the good news is y is my hypotenuse, and if you need to look back at your formulas, hypotenuse is 2 times the short leg. There it is. We just got the short leg, so let's use that. 2 times the short leg. Short leg is 4 radical 3, so I'm going to do 2 times 4 radical 3, which gives me 8 radical 3. You can multiply outside the radicals and multiply inside the radicals. You just have a 3 inside the radical. And those are my answers. Okay, hopefully that helps. And we went through 4 solid examples there of what these could possibly look like. So you have all of the tools that you need to think through these. And some of you, like I said, will be able to do this entirely in your head. No pressure. You don't have to write out what you need to. I'm going to end this video, and you're going to try some on your own. Great job, and I look forward to continuing to build on our knowledge together.